Recording. All right, so those of you who are here and those of you who are watching at home, let's see. So y'all, for week 11, which was actually like last week, um, the materials that we had or the stuff that y'all were supposed to do was going through 4.4 and 4.5. And then I'm going to pull up the one for week 12 because there's some info about the test and all that kind of good stuff. So there's three sections in chapter 4 that we still got to do: 4.4, 4.5, 4.6. Okay, and then and those homework assignments, y'all, are due by Thursday the 18th, which is not this coming Thursday, but the following Thursday. Okay, and there's also a quiz there. Let's see, and then y'all need to be working on the review. So guys, next Tuesday, 1 week from tonight. Hello, 1 week from tonight, what we'll be doing is we'll be reviewing for test 2, okay? So, like I said, there's 3 sections left in chapter 4. So, I don't know about you guys, but what my thought process was what I would do tonight is I would try to cover those 3 sections, okay? 4.4 is very short. 4.5 is a little bit longer, and then I'll answer some questions from 4.6, or we'll go over some stuff out of 4.6. And then remember, next Tuesday, y'all, is when we'll be reviewing for the test. So what I really want y'all to do between like now and next Tuesday is to be focusing on the review. So let's see. Yeah, my mic's on. Just wanted to double check that the microphone was on. Okay, so what I'm thinking I'll do tonight, y'all, is go over 4.4, 4.5, 4.6. I'll just like lecture on that. And then at the end of that, y'all, if y'all have any particular questions, we can definitely take some time going over that. Does that sound like a plan for you guys? Those are here? Okay, awesome, great. Antonio, I know you're watching from home at any point in time. Antonio, if you got a particular question, let me know, but I am going to go over 4.4, 4.5, and 4.6, okay? So, and if you got a question, you can just throw it in the chat, or you can turn on your mic and speak up, whatever is easier for you. So let's see, y'all. I'm going to get my calculator going because 4.4, y'all, a lot of it is just calculator type stuff, okay? And so 4.4 is evaluating logarithms and something called the change of base theorem. Okay, so what 4.4 talks about, y'all, is that anytime we just see the log of x, what they're telling us is that it's implied that my base number here is going to be 10, okay? And so, so for these first 3 problems, it just says, let's use a calculator to find these values, okay? So I'm going to grab my calculator, I'm going to turn it on, and I'm going to clear all this business out. And so what I'm going to do is on my calculator, there should be a button that says log. It's right here to the left of number 7. So I'm going to hit the log of, in this case, it's 1,000. And let's see, my answer is coming up to be 3, okay? And just to kind of give you an example, just so you kind of understand why is it 3, like why is it 3? Remember what we said the base number here? The base number here is 10, right? So y'all, if I come back and I think about the definition of a logarithm, like the one we were talking about the other day, and here it is in the logarithmic form, and here it is in the exponential form. So if I was to kind of do a little stare and compare, and I were to look at this part right here, and I were to compare it to this part, I would say, hey, look, my A is 10, and my X is 1,000, and I don't know what my Y is. So then if I were to write it in this form here, I would say 10 to some power is going to give me 1,000. And so I already know that 1,000 is 10 times 100, and I know that 100 is 10 times 10. So this would say 10 to the y is equal to 1, 2, 3 of them, 10 to the third. So then that's telling me that, hey, look, y has got to be equal to 3, right? And that's really all it's telling me. But I wanted to show you that just so, again, so we can come back, because, y'all, one of the most important things here and doing any of this stuff out of chapter 4 is really making sure that I understand that definition, okay? And I can go from the logarithmic form back to the exponential form and kind of vice versa, right? I can kind of move, I can go from one to the other. So, but again, these problems here, y'all, are going to be straight calculator problems, okay? So look, I'm going to do the next one. I'm going to do log of 142. So I'm going to go, again, I'm going to go log 142. My answer is going to be somewhere between 2 and 3. And there it is, 2.15, okay? And y'all, when you're doing these problems in my lab, it's going to tell you like round to 2 decimal places or round to 3 decimal places, but it'll be real specific, okay? So I'm going to round to, I don't know, I'll say I'll round to 3 decimal places. So I'm going to put 2.152. And same thing for the next one. Again, I'm going to use my calculator here. So again, I'm just going to hit the log, and I'm going to enter 0.05832 and close that off. And I'm coming up with a negative 2.234. So again, these problems here, straight calculator, all you're doing is using that little log button, okay? And the next problems here, same sort of thing here, y'all. These are using what we call the natural logarithm. So the natural logarithm, excuse me, just means that we're using the base of e, okay? And we saw that e in back in 4.2 when we had to do like the continuous interest business. But the number e, y'all, is just an irrational number. It comes up quite often, actually, like in natural occurrences. That's where we use it. But again, I'm just going to do this stuff right here on my calculator. So look, I'm going to use the ln button. So I'm going to go ln. And then if you notice right here, it says e. So the way I get to e, I'm going to go second ln. And my power is 3. And I'm going to close off both sets of parentheses because I had 2 that opened it up. And I'm going to hit enter, and if you notice, my answer is just 3, right? And I'm going to do the same thing for this one. I'm going to hit the ln of 142. So I'm going to go ln, and then 142, and I'm going to hit enter, and I'm coming up. I'm going to go ahead and go to 3 decimal places, y'all. So I'm coming up with 4.956. 4.956. And I got one more here. Again, ln. Where is it? There we go. 0.005832. And again, this is just straight calculator work, y'all. Whether you're using an actual calculator or whether you're using one of those apps like the Graph and Calc 83 or the Calculate 84, whatever it is, it's going to work exactly the same. If you actually, I don't know a whole lot about Androids because I have an iPhone, but if you just get to your, let me see. Where's my calculator? Here we go. Even if you just pull up the regular calculator on your iPhone, it kind of looks like this, and then you turn it to the side, you end up with a scientific calculator, and you're going to see the log button there, and you'll see the ln button there. I'm not, like I said, I'm not certain about those of you who have Androids, but again, you'll see those buttons right there. Again, whether you just do this, or whether you use one of those apps, or whether you got an actual calculator, they're all going to come out the same, okay? All right, so let me go ahead and hit enter here, and I'm coming up again with negative 5.114. Negative 5.1, I think it was 144. 144. There we go. All right, so again, these problems here, these problems here, y'all, straight calculator type stuff, right? They should be pretty easy breezy cover girl because you're not really having to do much other than can you operate your calculator, okay? So again, at any point in time, y'all have questions about any of this stuff, please don't hesitate to ask me. Okay, so now we're going to do something called the change of base theorem. So the change of base theorem says for any positive real numbers x, a, and b, where a is not 1 and b is not 1, then we can do something called the change of base. And I'm going to show you how this change of base formula kind of works, okay? So first thing, y'all, before I even get started, I'm going to write down again the definition of a logarithm, okay? And y'all, every single time that I'm doing these problems, this is always going to be like my go-to, okay? And I'm going to say, okay, look, can I do a little stare and compare? Can I look at what I have in my logarithmic form? and can I rewrite it so that it has an exponent, so that it has a power, okay? So look, y'all, we're going to do a little stare and compare here. I'm going to look at this problem right here, and it says the log base 5 of 17. So if I look at this part right here, would you all agree with me that my a is the number 5, and my x is the number 17, and I don't know what my y is just yet? And again, all I'm doing, y'all, I'm looking at this part, and I'm comparing it to that, right? And I say, okay, look, now that I have that part, how would I write this using my exponential form, right? And I would say, look, 5 to some power, I don't know what it is going to be equal to 17, okay? And if I start thinking about powers of 5, like I know 5 to the first power, it's just that number itself. And 5 squared is 25. And if I look at the number that I'm trying to get to, I'm trying to get to 17. So if I know that 5 to the power 1 is 5, and I know that 5 to the power 2 is 25, and I'm trying to figure out 5 to what power is going to give me 17, I'm going to tell you right now, y'all, my answer is going to be a number somewhere between 1 and 2, because if 5 to the 1 is 5, and 5 squared is 25, and 17 is between these two numbers, right? That doesn't look like a 17, does it? And if 17 is between those, it still doesn't look like a 17, but anyway, if 17 is between those two numbers, there we go, then my answer should be between those numbers 1 and 2, okay? So this is how we're going to do this, y'all. When we use the change of base formula, we're going to use what we just did on our calculator. We're either going to use the base 10 or we're going to use the ln, okay? We can't mix and match, but we're going to use one of those two because those are the ones my calculator knows how to do. So I want you to notice what we have here. It says the log base b of x divided by the log base b of a. So I'm going to say, look, let's just use the log of x, and we said x was 17, and we're going to divide that by the log of 5. And remember what we said our answer is. Our answer should be a number somewhere between 1 and 2, right? So look, I'm going to take my calculator right here, okay, and I'm just going to do this on my calculator, y'all. I'm going to go log 17. Now my calculator, y'all, the calculator that I'm actually using opens up parentheses. So I need to close those off. And I'm going to divide this by the log of 5. And again, it opened up parentheses, I'm going to close it off. Remember what I said? My answer should be a number somewhere between 1 and 2. So when I hit enter, check it out, 1.760, right? So right here, I'm going to say 1.760. Before I go on, did it make sense on why I said my answer should be a number between 1 and 2? Were we good with that part? Because I already knew that 5 to the power 1 was 5, and 5 to the power 2 was 25. And what we were trying to figure out was 5 to what power would give me 17. And because 17 is a number between 5 and 25, then my answer should be a number between 1 and 2. So that's kind of why I did that, y'all, so that even though I'm doing this on my calculator, I can say, hey, you know what? I have an idea of where my answer should be, right? And the reason why I wanted to do that is, let me ask y'all a question. Before the last week or two, how many of y'all had seen that logarithm stuff before? Or if you had, it had been like a ridiculously long time, right? Either it had been a really long time, or maybe you hadn't seen it, or maybe you saw it and you're like, you know what, I've been out of high school for 18 years. Did I see it? Just hands out, and maybe I did, right? But the reason why I want us to have an understanding, you know, hey, you know what, my answer should be between 1 and 2, is because of this. When we do this stuff on our calculator, y'all, whatever answer we get on that calculator is la palabra de Dios, right? It's the word of God. You don't ever question it, right? That's just what I got, so that's what I'm going to put. But if at least I know that, hey, you know what, my answer should be between 1 and 2, I can at least say, hey, look, I got an answer between 1 and 2. I'm feeling better about this. You know what I mean? So look, let's do the same thing for the next one here. It says the log base 2 of 0.1. Okay, so remember, y'all, I'm going to do this. I'm going to write y equals the log base a of x means that a to the power y is equal to x, right? So when I come back here, oops, and I look at this part, I can say, hey, look, my a is 2, my x is 0.1, and I really don't know what y is. But I can use this part, and I can say, look, 2 raised to some power is going to give me 0.1, right? So y'all, before we said that any number to the power 1 is going to give me that number itself. So I would know that 2 to the power 1 is going to give me 2. Now, I know we talked a little bit about this the other day, but if you forgot, it's okay because I'm going to tell you right now. Any number, y'all, raised to the power 0 is going to give me 1, okay? And if I look at this number, that's 0.1. Well, 0.1 is smaller than 1. And so if I kind of go backwards one more, 2 to the power negative 1 would be 1/2. And as a decimal, y'all, that's going to be 0.5. That's still bigger than this number, okay? So I'm going to say, okay, well, what about 2 to the power negative 2? That's 1 over 2 squared, or 1/4, which is 0.25, like a quarter, right? 1 out of 4 quarters is 25 cents. And then I'm just going to kind of keep playing this game. You don't necessarily have to play this game, y'all, but again, I want you to kind of understand, like, hey, what kind of answer should I get? 2 to the power negative 3 would be 1 over 2 to the third, 1 over 8 as a decimal, 0.125. And so this number is still bigger than that one. So I'm going to go one more. What about to the negative 4? That's going to be 1 over 2 to the 4th, which is 1 over 16. I have no idea what that is as a decimal, so I'm going to check. It's 1 divided by 16, 0.0625. Okay, 0.0625. Here we go. Okay. Again, just to show y'all, this number, 0.01, is, let's see, is between, actually it's even smaller than, oh, it's 0.1, not 0.0. There you go. So 0.1 is somewhere between this number here and this number here, right? Because this is like 0.100. You can think about it that way. And so what I know is because this number here is between this one and this one, my answer should be somewhere between -3 and -4, right? Okay, and again, I'm just doing that just so that I get an idea, right? It's not that I don't trust my calculator. I trust my calculator a whole lot. But remember what I'm going to do now. I'm going to say, look, I'm going to take the log of 0.1. I'm going to divide it by the log of 2. I want you to think it's the base because it's not the base. And this is where I'm going to use my calculator. So I'm going to go log of 0.1 or 0.1 divided by the log of 2. And I'm going to hit enter, and look what I'm coming up with, -3.322. So -3.322. And I said, hey, you know what? My answer should be somewhere between -3 and -4. So again, at least I have an idea, right? Guys, my calculator is going to work every single time. The only time that I get a wrong answer is because I'm going way too fast and I hit the wrong button, or I got big old fat fingers, so when I hit it, you know, I hit more than one key or something like that. But the calculator is always going to work. Now, I want to mention something, y'all. The change of base formula, whether I use the log button or whether I use the ln button, it's not going to make any difference. I'm going to do just a little bit of cleanup right here. I'm not going to erase too much stuff, but I'm going to do just a tiny bit of cleanup right over here. And when we did our problem, look what we used. We used the log button, right? Y'all, whether I use the log button or the ln button, because those are the two that my calculator knows how to do, I'm going to get the same thing. Look what the answer is. The answer is 1.760. So just so you know, if I do ln of 17, don't forget to close the parentheses, divided by the ln of 5, again, don't forget to close the parentheses, I come up with the exact same answer, 1.760, right? Which one do I use? It doesn't make any difference. I'm going to end up with the same thing. The only thing is this, y'all. If we go with the log on the top, we got to go with the log on the bottom. If we go with the ln on the top, we got to go with the ln on the bottom. We can't kind of mix and match. You know what I mean? So either way you do it, it really doesn't make any difference. You're going to end up the same thing. And we could have done the same thing here. Oops, let me kind of scroll down a little bit. We could have done the same thing here with this one, y'all. We could have used the ln. Okay, which one do you prefer? It's up to you, right? You're going to get the same answer either way. Just remember, if you use log on top, use log on bottom. If you use ln on top, use ln on the bottom. Okay, and then don't forget to, again, it's all dependent on your calculator, but like I know mine opens up those parentheses, so don't forget to close them off, okay? If you don't close it off, y'all, then it's taking the log of, like, say, 17 divided by the log of 15, as opposed to the log of 17 divided by the log of, 5. It'll do it that way, okay? So just watch those parentheses. Okay, that's why I said 4.4, y'all, super short section. Look, we've been here 20 minutes, and we're done with the first one. Okay. All right, so 4.5, y'all, is exponential and logarithmic equations. And so I'm going to kind of give you guys some hints on how do you solve these types of problems. Anytime you're solving an exponential equation, now the reason these are called exponential equations, y'all, is if you look for the x's as the exponent, okay? That's why we call them exponential equations. So again, if I look at my problem, the problem we have says 3 to the power x is equal to 7. So again, if I were just to kind of think about this, right? Like, what does that mean? Well, I know that 3 to the first power is 3, and I know that 3 squared is 9. And I'm trying to figure out 3 to what power is going to give me a 7. Well, 7 is a number between 3 and 9, right? So if 3 to the first power gives me 3, and 3 to the second power gives me 9, then my answer should be a number somewhere between 1 and 2, right? Because that would tend to make sense. Anytime you have a problem that's exponential like this, y'all, what we're going to do, we're going to take the log on both sides. So I'm going to write it like this. I'm going to write the log of 3 to the power x is equal to the log of 7. So I'm just taking that logarithm on both sides. I'm just writing the log in front of that, okay? Now, the reason why I'm doing that, when we were here a week ago, last Tuesday, and I'm just going to kind of scroll back. I just want to show it to you, and then I'll come back and explain what we're doing. Let me see if I can find it. It should be right about here. Here we go. So this was in 4.3, I want to say. And there was something called a power property. And the power property said if we had an exponent, if we were taking the logarithm of an exponent, that exponent could come all the way down to the front, okay? So that's what I'm going to do here, y'all. I'm going to zoom out of this business, and I'm going to come back to our original problem where we were, right here, okay? And this exponent, y'all, can move down to the front. So it's going to be the log x times the log of 3 equals the log of 7. Okay. Now, since I'm trying to solve for x, I'm trying to get my x by itself, and this is being multiplied, I'm going to divide both sides by the log of 3. So that this one and that one are going to cancel out. And so the exact answer, y'all, would be the log of 7 divided by the log of 3. And then if I take my calculator and I do this on my calculator, I'm going to say, look, let me take the log of 7, don't forget to close your parentheses, divided by the log of 3, I'm going to close my parentheses again. If y'all remember, y'all, I said my answer should be a number somewhere between 1 and 2, and look what I'm coming up with, 1.771, right? So what that tells me is like, hey, you know what? I'm on the right track because I know what kind of answer I should be coming up with, okay? Now, y'all, that kind of explanation that I'm giving you, I don't necessarily want you to do that with every single problem, but just think about it, maybe for one of them, right? Just so, again, you can say, okay, what is it I'm trying to find here? I'm trying to see how can I write this or that, or, 3 to what power would give me 7, And it's not always going to be like something so easy like that one. I think it makes a little bit more sense. Sometimes, like if I look at the next one, 1/2 to what power is going to give me 5? I don't know, right? I can't think of that one off the top of my head. But it doesn't matter because I can use the same properties, the same process, the way I solved the first one, I can do that with this one here too. So look, the first thing I'm going to do is I'm going to take the log on both sides. So this is going to say log of 1/2 to the power x is equal to the log of 5. Okay. And then this power of x, y'all, is going to come down to the front. So it's going to say x times the log of 1/2 is equal to the log of 5. Go back to my black marker. And then we'll just divide everything by the log of 1/2. Okay. So this is telling me x equals the log of 5 divided by the log of 1/2. And again, I'm going to use my calculator here, y'all. I'm going to move this over so you can see everything. And I'm going to enter it in exactly as I see it. So on my calculator, I'm going to say log 5, close my parentheses, divided by the log of 1 divided by 2, close my parentheses again, hit my answer, and here I'm coming up with like negative 2.32 if I go to 3 decimal places. So negative 2.32, 322. There we go. All right. I'm sorry? Well, what I'm saying, Lauren, is when you're doing your homework in my lab, it's going to tell you round to so many decimal places. Okay, so right now, I don't remember off the top of my head how many it's telling me to do it. So what I'm doing right now off the top of my head, I said, look, let's just go to 3. But if in my lab it tells me round to 2, then I'll round to 2. But it's going to tell you to do some rounding there. I'm sorry? Go to 4? Okay, so we'll, what was that? For the next ones, we'll go to 4, okay? Let's see. All right, we got some people here. Let's see. I'm going to stop sharing the screen real quick. Those of you who are here, y'all, if you have your mic on, can you turn it off? I don't know. I heard like a little thing there, so I just want to make sure everybody's good. But I'm glad those of you who are here, Antonio, Laura, and Robert, I'm glad you guys are here too. Excellent. Okay, so look, y'all. Again, remember what I said earlier in, I'm sorry, I heard something in the chat. Let's take a look. Good, good. Everything is going so good. I'm sorry? It was something up here? Okay, maybe it was in our room, y'all. Okay, so y'all remember when we went through 4.4, the first section, we talked about those 2 logarithms that our calculator can do, either the log or the ln. So again, y'all, with these problems, I can either choose, do I want to use the log, do I want to use the ln? It's really up to you. In my experience, y'all, most of my students, and like I told you, I've been doing this since like 1997, so I don't even know if some of you guys were even around here yet. But when I've been doing this, everybody says, sir, do I even have to do the ln business? Like, no, you could always do the log. It's always going to work, okay? You don't have to worry about it. I mean, there's times when I am going to use ln, and I'll explain when I'm going to do it, but if it's just easier for you to stick with one of them, stick with that one. It's always going to work, right? And if it's easier, if you say, like, I don't know, I just always hit the ln button, that's always going to work too, okay? It really doesn't make any difference. So let's do the same thing here. We're going to take the log on both sides. Okay. Again, my exponent here, y'all, is going to come down to the front. And I'm putting these in parentheses, y'all, just because of the way my calculator does this, right? And then I'm going to go ahead and divide everything by the log of 0.8, right? And so those are going to go away. And okay, so Arida, you were saying that it's asking us to go to 4 decimal places, so we'll do that here, y'all. So look, I'm going to go log of 4, close my parentheses, divided by the log of 0.8, and I'm going to hit enter. And if I go to 4 decimal places, y'all, I'm coming up with negative 6.212. I would round that 5 up to a 6 because the number to the right of it is a 6 also, so that's going to change that number up. So negative 6.2126. Is that what we had? Yeah, 2126. Again, the number to the right of the 5 is a 6, so it's going to move that 5, going to bump it up by 1, right? And there we go. Okay, so now let's take a look at this one. So we got a little bit more exponential stuff going on here, and it definitely has a whole lot of business going on, okay? So, guys, before I get started, do you remember this rule? If I have x squared times x to the fourth, my answer is x to the sixth. And the reason is, what are we doing with these exponents? Excuse me, we're adding them together. Okay, I want you to look at what I have here. We're multiplying those two e's. So what am I going to do with their exponents? I'm going to add them together. I'm going to say this is e to the power 3x minus 7 plus a negative 2x. And 3x plus a negative 2x is just a positive x. I'm sorry, not a plus 7, but a minus 7. So all I did is just combine those two terms there, is equal to 4e. All right. So, y'all, I told you occasionally I am going to have to use the ln. Now, the reason why I want to use the ln, and I want y'all to look here, I wish I could make the calculator bigger, y'all, but I want you to look right above the ln, there's that e, right? So the reason why I want to use the ln here, so what I'm going to do, y'all, I'm going to take the ln on both sides. Okay. The reason why I want to do the ln is when I'm dealing with the ln and the e, those pieces right there, y'all, are going to cancel out. This is going to give me an x minus 7. Okay, I'm going to show you how I'm going to sort of break this part up. Earlier, a little while ago, I scrolled back up to the top, and I'm going to see if I can find it. It's probably in 4.3, and here it is. It's the top one. This one on here, the product property says, if I'm taking the logarithm of two things that are being multiplied, then I can separate it as the log of the first one plus the log of the second, okay? And again, I know this was from 4.3. I know it was a week ago that we talked about it, but that's why it's there in the notes, y'all. And when we get ready, when we have test 2, I did put a formula sheet there for y'all, and I included this in there, okay? So you'll be able to reference that. So let me scroll back over here so I can get back to where we was. Here we go. Okay, so when I'm at this part right here, y'all, I'm going to separate this as the ln of 4 plus the ln of 8, okay? So this is going to give me x minus 7 equals the ln of 4 plus the natural log of e. If you're curious how to do it, you can just grab your calculator and say, look, what's the ln of e? Now, what's my power in the e? If I don't see a power there, y'all, it's understood to be 1, okay? Close the powers again, or parentheses, I'm sorry. Look what my answer is. My answer is just nice and pretty 1. So plus 1. Remember what I'm trying to solve for here, y'all. I'm trying to solve for x. So I'm going to go ahead and add 7 to both sides. Okay. So that's going to cancel these, and that's going to give me with an x equals the natural log of 4 plus 8. This here, y'all, is what we call the exact answer. Okay. Now, I'm going to go ahead and, because again, MyLab is going to ask us for a decimal answer, right? So the way I'm going to do this on my calculator, y'all, I'm first going to find what's the ln of 4, and then I'm just going to add 8 to it. So because it has the ln, y'all, because I use the ln, I have to use the ln. I can't just say, oh, let me start doing the log. I got to keep with the ln, okay? So I'm going to go natural log of 4, close my parentheses, add 8 to it, and the answer I'm coming up with is 9.3863. 9.3863. Again, if you look at my calculator, y'all, the number to the right of the 6 is a 2. The number to the right of that is a 9. So that 2 is going to bump up to a 3. And there I am with my decimal approximation, okay? All right, so let me ask you a question. Before I go on, out of the problems that we had done so far, so look, we did 3 to the power x equals 7, 1/2 to the power x equals 5, 0.8 to the power x equals 4, and then we had this one. This was probably the more complicated one, right? Because we had there was different parts, right, compared to the ones we had done before, right? So I'm hoping that like this part here makes a whole lot more sense, right? And I need to double check y'all, but I think on the test I gave you guys something more like this instead of something like that. Okay? I think I have to go back and double check, but we'll make sure it looks something like that. Okay, so now the next one here says solve. We're going to give an exact answer. Okay, so I know it's been a long time since August, and we started the semester in August. And when we were here in August, we did some factoring, and then we did some problems that were kind of like in quadratic form, and that's kind of how I'm going to do this part here, yeah. So, and I know it's been a really long time, but in case you forgot, I'm going to show you. I'm going to say that I'm going to introduce this dummy variable. We call it u, and I'm going to say like u is equal to e to the x. So then u squared would be e to the 2x, okay? And what I'm going to do is I'm going to rewrite this problem using this here. So look, e to the 2x. Hey, that's what I'm calling u squared. So I'm going to write this as a u squared minus 6 e to the x. Hey, look, that's what I'm calling u plus 8 equals 0. Now, I know how to do these problems because we can do this by factoring. So remember, y'all, the number in front of this u squared is a 1. So when the number in front is a 1, these should be like the more easy cover girl problems to factor. I'm going to take 1 times 8, which is 8, and I'm going to ask myself, what two numbers multiply to 8, but when I add them together, give me a negative 6? Well, I know the numbers that multiply to 8 are 1 and 8 and 2 and 4, and if I add these numbers together, I'll get a positive 6, but I really want to get a negative 6. If we do that, there you go. Look, negative 2 times negative 4 is still a positive 8, but if I add them, there's my negative 6. And then, y'all, we can just do this. We can go u and u, it's all about u. And then we're going to use those two numbers right there, minus 2 and minus 4. And then we're going to set each part equal to 0. So here, u is going to be equal to 2. And here, u is going to be equal to 4. And let's see. And then the next thing I'm going to do, y'all, is remember what u is equal to? U was the same thing as e to the x. So right here, y'all, I'm going to say e to the x equals 2, and e to the x equals 4. Now again, since this one here, y'all, is dealing with the base of e, I'm going to take the natural logarithm on both sides. Okay. So what happens is the natural log and the e cancel out. X equals the natural log of 2. The natural log and the e cancel out. The x is equal to the natural log of 4. So I'm going to zoom out just a little bit so y'all can see what we did. But one of the things I really want to emphasize, y'all, is when we did this part right here, that was just a factoring problem. And we did factoring like 100 times, right? We did that back in August and September. The only part that's really kind of new was that part right there, where we were having to use some of that logarithm stuff, right? But again, if I see E, that tells me automatically, let me use my ln, okay? If I see the E, I'm always going to go with my ln, all right? And since this problem here, y'all, said give the exact answer, I'm not going to do the decimal part because it was asking for an exact answer. And I want to say in your homework, you have a problem very similar to this, okay? And when it asks for the exact answer, that's all they're asking me to do. They're asking me to go like ln2, ln4. And I tell you what, I'm going to scroll. We got a couple more problems to do dealing with logs. Before we do that, y'all, I am going to pull up my homework. Oh my goodness, where are we? Here we go. Close that off. I am going to pull up my homework from, this is section 4.5, I want to say. And I'm going to pull up a problem because I want to say there's a problem very similar to that one in our homework. So let me scroll. Here we go, 4.5. All right, I want to look at question number 3. Maybe it's 3 out of my opportunity. No, not that one. Here we go. So look, this problem here, y'all, is almost like the one that we just did. Okay. So let me this. Let's go copy. Let's come back over here, and what we're gonna do here, y'all, is we're gonna go paste. Boom. There it is. Okay. So it says solve the following equation, and it says what is the solution in terms of natural logarithms? Select the correct choice below, and if necessary, fill it in the answer box to complete your choice. Okay, so look, first thing I'm gonna do, y'all, do what we did before. I'm gonna say that u is e to the x, so that u squared is e to the 2x, okay? And then what I'm gonna do is I'm gonna come back and I do some substitution. Where I have my e to the 2x, that's the same thing as u squared. So I'm gonna write that as a u squared minus 9. E to the x is the same thing as plus 20 equals 0, okay? So now that we have that part, y'all, I'm going to do this just like we did the problem before. So look, I'm going to say, look, the number in front of my u squared is a 1. So I multiply the first number and the last number, always the first and the last. 1 times 20 is 20. And when I think of the numbers that multiply to 20, these are the numbers that come to my mind. 1 and 20, 2 and 10, 4 and 5. We want them to add up to what kind of 9? Almost negative 9, right? Excellent. Very good. Negative 9. I heard that, y'all. Excellent. So look, y'all, 4 and 9 add up to positive 9, but if I go negative and negative, that still gives me my positive 20, and there's my negative 9, right? So look, we're going to go one step at a time. We're going to go u and u, and we're going to use those two numbers, minus 4 and minus 5, okay? And then we're going to say, look, oops, come on, pen. We're going to say u minus 4 equals 0, and u minus 5 equals 0. And I heard something in the chat, so let me come back to the chat real quick. And I'm sorry, you can't hear? Let's see. I'm not sure why you can't hear. Those of you who are at home, can anybody else hear me? Those of you who are at home? Lauda and Robert, can you guys still hear me? Let's see. Maybe they can't. Okay, you guys can. Okay, excellent. Antonio, I'm not certain what's going on with your volume, sir, but Robert says he can hear me. Okay. And you know what? Let me put that in the chat real quick because you probably couldn't hear that either. All right. Antonio, you may need to restart your computer because okay, there we go. All right, so let's go ahead and finish up this problem. So look, y'all, when we move the 4 over, it's going to become positive. When I move the 5 over, it's going to become positive. Remember what we did from the very beginning? We said u was e to the x. So right here, y'all, I'm going to say e to the x equals 4. E to the x equals 5, right? Okay, so remember, since I have the e, what I'm going to do, y'all, I'm going to take the ln on both sides. Okay, when we do that, the natural log and the e are going to cancel each other out. The natural log and the e are going to cancel each other out. And look what we came up with. We got our two answers, the natural log of 4 and the natural log of 5. Okay? Now, I want to show you, and I'm going to go and enter those answers in, right? Look what we did earlier. When we did it, we came up with the natural log of 2 and the natural log of 4, right? Now we got natural log of 4 and 5. Let me see, I heard something in the chat. Okay, excellent. I'm glad you can hear me now, Antonio. So, oops, here we go. Okay, so look right here, y'all. I'm going to type in my two answers. The natural log of 4, comma, the natural log of 5. Notice, see how it's doing it when I type in, and I'm just using my keyboard, y'all. See when I type in my ln, you see how it looks like they're almost bold, right? It's like in bold font. So that's telling me, hey, it's using that, it knows, it's recognizing, hey, he's talking about the natural logarithm. He's not just typing the letters L and M, okay? And then I'm going to go, let me go chickadee check. Yeah, you don't have to put the little X. Guys, so by the way, I know some of that's happened to y'all before. If that happens to you, say when you're taking a quiz and you put X equals, right? Or even when you're taking the test and you put X equals and it counts it wrong because all it wanted is L and a 4, L and 5, do me a favor, take a picture of the problem, send it to me, right? Hey, sir, look, I got the exact, I wrote the same thing. It's just I put X equals, X equals. Don't worry about it. I'm going to give you credit. Don't sweat it, okay? I'll get you guys there. Yes, ma'am. Oh, this one here, the empty set? Okay, so I'm going to tell you right now, Adidan, you're not going to get the empty set. Okay, so you don't even have to worry about it. You don't have to worry about it. You're not going to get the empty set on these problems, so. So my whole thing is, like, so I'm going to tell you right now, I have a pretty good feeling that problem comes out on the test because I think it was last semester too, and I haven't changed my test. But what I would tell you is, like, practice this problem, right? So you know you have this problem, and again, you're going to see it in the review too, right? But do the problem, right? Whether you're doing it here, whether you're doing a review, if you get it right, just do me a favor, take similar questions. Do it one more time, right? I'd much rather you have it and say, okay, oh man, this is going to be good. I know I can do these here. Like I said, y'all, next Tuesday, we're going to review for our test, okay? So let's keep going. I'm going to come back over here. All right. And now what we're going to do is we're going to figure out, so we've done the first part of 4.5. We figured out how to solve exponential equations. What we're going to do now, y'all, we're going to solve logarithmic equations, okay? And I'm going to show you how I'm going to do these. So for every one of these problems, y'all, I'm going to use the definition of my logarithm, okay? And what I'm going to do is I'm going to see it in in my logarithm form, and I'm going to figure out how to write it in my exponential form. Okay. So first thing I'm going to do, I'm going to zoom in real quick because I want y'all to understand when I have that 5 in front, y'all understand it means it's being multiplied, right? So what I'm really trying to do is I'm trying to get this piece by itself first. Okay, I'm trying to get that ln by itself. So what I'm going to do is I'm going to divide both sides by 5. Okay, and that's going to give me the natural log of x is equal to 2. Okay, so just in case you forgot, y'all, the natural log of x is the same thing as the log base e of x. Okay, that's really what it means. Okay, so when you see ln, what should come to your mind is, hey, you know what? The base here is e. Okay, that's just how it is. We write it using natural log, but you could write it as the log base e. It means the same thing. The reason why I wanted to write it like this is I'm going to do a little stare and compare. I'll say, hey, look, my a number is my e. My x is still x, but my y number now is the number 2. Everybody agree so far? Okay, and then what I'm going to do, y'all, I'm going to write it like this. So I'm going to say, look, what's my a number? Oh, it's e. To what power? To the power 2 is equal to x. And we solve for x. X is already by itself. And that's all we have to do. And since it says give the answers in exact form, I'm not going to do anything any different. Are we okay so far? Yeah, we're good? Okay. All right. Let's take a look at the next one here, y'all. We're going to do the same thing. Remember what we said we want to get by itself? We want to get the x by itself, right? Okay. So I'm going to write it like this. I'm going to say, remember my definition. It says y equals the log base a of x means the same thing as a to the power of y equals x. So when I look at this problem, y'all, I'm going to write it like this. The log e of 4x, and I'm putting that in parentheses because it's not just an x, it's really a 4x, is equal to 1.5. Okay, now let's do our little stare and compare. So if I look at this here, y'all, and I look at this part here, I can say, hey, look, my a number is really e. Instead of an x, I really have a a 4x, right? I don't just have an x by itself, I got a 4x. And my y number in this case is a 1.5. Before I go on, are we good on how I wrote those parts down? Flavia, am I good? We're all good here? Okay, just checking with y'all. Look, y'all, now I'm going to use this to write it like this. So I'm going to say a, which is really e, to what power? To power 1.5 is equal to not just x in this case, but 4x. Now remember, I'm trying to solve for x. So how do I get rid of my 4? We can divide. And we come up with x is equal to e to the power 1.5 all over 4. And that's all I'm doing. That's exactly right. So every single time, y'all, I want you to notice, with both those problems, the first thing I did is I wrote down the definition of logarithm. Y equals the log base a of x is the same thing as a to the power y equals x. And then once I do my little stare and compare and I can find my a, my y, and my x, then I can go ahead and say, okay, how can I put this in the exponential form? And then I'm done, okay? And every time I see the ln, I'm just gonna write it, y'all, with the log base e, because that's gonna help me figure out what my base number is, okay? Okay, so now, we're gonna take a look at the next problem that I have here. I want you to notice there's not a base number written, right? It doesn't have the little number on the bottom. When it doesn't have the little number on the bottom, y'all, what you can do, get my pen going, the base number is 10, okay? When it doesn't have the number written at the bottom, the base number is always 10. When it has the ln, the base number is 8. Okay, so like I said before, this is the first thing I'm going to do. I'm going to write it like this. Let's say a to the y equals x. So I'm going to do a stare compare. I'm going to look at this, and I'm going to look at this. And I'll say, okay, look, my a is the number 10. I don't really have an x, but I have a 2 minus x, because that's what I got. Oops, that's what I got right there, right? And then my y number is 0.5. Okay, so let's see if we can do this. So we're going to go super slow here. We're going to say a, which is 10 to the power y, 0.5. Oh, come on, pen. 0.5 is equal to 2 minus x. So now, I want to solve this problem for the letter x. So I'm going to say, look, let me go minus, oh, come on, pen. Let me go minus 2 and minus 2. So 10 to the power 0.5, oops, minus 2 equals a negative x, right? Because I still have that negative in front of the x. So y'all, what I'm going to do now, I'm going to multiply everything here by negative 1, and that's going to give me negative 10 to the power 0.5 plus 2 is equal to x. And I am done. Just to give you a hint, y'all, if you want to, you can also write it like this. Look at the sign of the 2. The sign of the 2 is positive. Hey, the sign of the 2 is positive. Look at the sign over here. It's negative. Oh, look, it's negative, right? Whichever one you want to write it, you get the same thing, okay? So far, are we doing okay? Not too bad? Okay. So look, let's try this next one here. Again, first thing I'm going to do, y'all, I'm going to write down my definition. I'm going to say y equals the log base a of x is the same thing as a to the power y equals x. Okay, so I'm going to look at this part here, and I'm going to look at this part here. Y'all know what my a number is here? Look at the a number. It's the little number down here at the bottom. It's a 6. Good, perfect. Instead of an x, we really have, what, a 2x before? Okay. And instead of a y, we really have the number 2? Okay. So we're going to take that, and like Claudia said, we're going to write it in the second form, right? We're going to plug in the second form. So I'm going to say 6 squared is equal to 2x plus 4. Okay. Remember what I'm trying to solve for. I'm trying to solve for x. Y'all know what 6 squared is? 6 squared means 6 times 6, which is 36. Good. Equals 2x plus 4. So look, let's go minus 4 and minus 4. So 2x is equal to 36 minus 4 is 32. And then we're going to divide both sides by 2. And we should come up with 16. So again, the whole idea here, y'all, excuse me, let's take our problem, let's write it in the, let's write the definition of the logarithm, and then let's find our a, our x, and our y, write it in that exponential form, and solve, and then we're done. All right. Okay, so let's take a look at the next one that we got over here. And it says the log x of x plus 15 equals 2. Okay, so y'all, I'm going to pull something up real quick, just so I don't have to keep scrolling around as much. Let me come back over here. Here we go. In the week 12, there's a formula sheet that I told y'all you're going to have access to for test 2, okay? So I'm going to scroll through here. I want to see if I can find the part that I'm looking for. Here we go. These are where those properties were. Like I kept on scrolling back and forth. But I want you to notice that first one here, it says product property. If I am adding 2 individual logarithms, we can multiply what we're taking the logarithms of together, okay? Now, the reason why I'm looking at that is when I look at this problem here, we got a plus right here. So that means that we can multiply these pieces together. So I'm going to write it like this. The log of x times x plus 15 is equal to 2, okay? Now, the reason why I want to do that is so that when I think of my definition of the logarithm, when I look at this part, I only see the logarithm written one time. And when I look at this part, again, I only see my logarithm written one time, right? Okay, so the first thing is I have to find my a, my x, and my y. So, y'all, I want you to notice there's no number written down here, so it's really going to be the number 10, right? That's what we call the common logarithm. If you don't see a number down there at the bottom, it's always going to be the number 10. So I'm going to say, look, a is 10, and I don't really have an x. I really have an x times x plus 15, and my y is really the number 2, okay? Okay, so now we're going to go ahead and write this. We're going to say a to the power y. So we're going to say 10 squared. 10 squared is equal to x times x plus 15. So 10 squared, y'all, is 100. And I'm going to go ahead and multiply this out. That's x squared plus 15x, okay? And what I'm going to do here, y'all, is I'm going to go ahead and subtract 100 on both sides, so that now I have 0 equals x squared plus 15x minus 100, okay? And what I'm going to do here, y'all, is I'm going to do a little bit of factoring, okay? So remember how we've been doing this before? The number in front of that x squared is a 1. So I'm going to take the first number times the last number. So the last number is actually a negative 100. So 1 times negative 100 is still negative 100. And I'm going to start thinking of the numbers that I know multiply to 100, like 1 and 100, 2 and 50, oh, I don't know, 4 and 25, 5 and 20, and I guess 10 and 10 would be the last one. Okay, so I want to find the numbers that multiply to a negative 100, but when I add them together, I'm going to get a 15, okay? So let me ask you a question, y'all. If I made that into a negative 5 and a positive 20, do you agree that when we multiply, we would get a negative 100? So negative 5 times positive 20 gives me a negative 100, which is what I'm trying to find. And when I add them together, I'm going to get a 15. Okay. So those are going to be my numbers that I'm going to use. So I'm going to go like this. 0 equals, and I'm going to just put my two parentheses with an x and an x, and I'm going to use exactly those numbers that I got right there. A minus 5 and a plus 20. So when we set each part equal to 0, we're going to come up with x equals 5. And over here, we're going to come up with x equals negative 20. Okay. Now that we got that part, y'all, one of these answers I'm not going to use. I'm not going to use that. The reason I'm not going to use it is it's negative. And when I'm taking the logarithm of my, answer, of my values, whatever I take the logarithm of cannot be a negative number, okay? So look, I'm going to come back to the formula sheet. Let me see where it is. If you notice right up here in the formula sheet, y'all, to the very, very top, I'm trying to circle it kind of with my cursor. It says x is greater than 0. That just means that my x numbers are going to be positive, okay? So it says x has to be positive, y has to be positive, a has to be positive. But look, those are the numbers that I'm taking the logarithms of. Those logarithms I have to be taking the logarithms of positive numbers. So when I come back to this problem here, and we came up with a negative 20, that's something I can't use that one, okay? So when I'm doing this in my homework, if I come up with two answers and one of them is positive and one is negative, I'm only going to use the positive one, okay? I'm not going to use the negative one. All right, so, wow, look at that, y'all. That was all of 4.5, okay? So I'm going to show you guys 4.6, and this problem right here, y'all, we're going to skip it because you don't even have one like this in your homework. I thought you did, and I made the video of it, but we're going to skip it, so we only actually have a handful of problems to do for 4.6. So again, y'all, I'm going to go through these couple of problems from 4.6. Like I said, y'all, next Tuesday, what I really want to do is review for test 2, okay? So remember, the review is open. I think I told you guys I'm going to come back over here and check one more time real quick just so I can see where it is, Here we go. Okay, so look, y'all, the review has 42 questions. The test has exactly 20. I thought test 1 had 20 and it had like 24, but test 2, guys, has exactly 20 questions. I took those questions out directly from the review problems, okay? So 42 problems. If you haven't started working on it, start trying to do, just even if you do like 5, 6 problems a day, y'all, by next Tuesday, you'll have it done, okay? I wouldn't recommend like waiting till Sunday. If you can just do like 5 problems a day, you should be good, okay? And then the ones that you don't know, just like mark them, right? So next Tuesday, sir, can we go over this one, this one, this one? We got a whole hour and 45 minutes next week, y'all, okay? We'll have plenty of time to go over that stuff. Okay, so 4.6 is applications and models of exponential growth and decay. So it says, let y0 be the amount or the number at the present time t equals 0. Then under certain conditions, the amount present y at any time is modeled by this equation here. Okay, so let me give you the rundown how we're doing this. Here's our problem. It says a sample of 500 grams of radioactive lead 210 decays to polonium 210 according to this function. Okay, so we have a certain amount of radioactive lead, just like anything, stuff decays, and it's going to decay to this polonium 210 according to this function here. Okay, so it gives me a function, and it tells me t is the time in years. That part's really important to me, y'all, so that I know what the variable stands for. So A is the amount, t is the time in years. Now, it says, find the amount of radioactive lead remaining after part A says 4 years, B says 8 years, C is 20 years, and D says 5.5 life. I'm going to show you how to do each of these parts. So let's go one piece at a time. We're going to figure it out after 4 years. So after 4 years, y'all, this is what we're going to do. We are going to find the value of a of 4. So what does that mean? That means I'm going to come back to this problem, and everywhere I have the letter T, I'm going to plug in the number 4. So I'm going to write 500 e to the negative 0.032 times 4. Okay, y'all, so this here is going to be a strictly calculator type problem. So whether you're using a calculator, whether you're using your calculator app, it really doesn't make any difference. I'm going to show you how to do this, and I'm going to type in 500. Okay, now remember, I want to get to the E. So I'm going to hit my second and my LN button, and that little E should be popping up there. And notice my power, it's a negative. So I'm going to put negative 0.032 times 4, because that's the number that I got, okay? And I'm going to close off those parentheses, and I'm going to hit enter. And I want to say, y'all, because I did this problem with one of my students last week, I want to say that when you're doing this in my lab, it's going to ask you to round to the nearest whole number. So we're actually going to round to the nearest like whole number. So here I would say 440. So my answer for this one here, y'all, would be 440, because if you notice it's 439.9, it gets rounded up, okay? Now look at part B. Part B says, can we do this now in 8 years? Well, if you know how to do it in 4 years, we can figure it out in 8 years. All we're going to do is the same thing that we had, but instead of times 4 years, now we're going to do it times 8. So let me show you all something, guys. Whether you're using your calculator or whether you're using a calculator app, there's an easy breezy cover-go way of doing the same thing. Instead of you having to type everything out again, hit the second button and hit the button that says enter. And it types in exactly what you just typed in before. And then all I'm going to do is I'm going to use my little arrow button right here, and I'm going to change that from a 4 to an 8. And I'm going to hit enter, and I'm coming up with 387. Right? Okay. And then part C says, can we figure this out in 20 years? Of course we can. Oops. Okay. So I'm going to do the same thing I did before. If I want to type in exactly what I did, I'm going to go second and then enter, and it types in exactly what I had before. And I'm just going to change that 8 to a 20, but I got to close my parentheses off again. I'm going to hit enter, and I'm coming up with 264 if I round to the nearest whole number. Okay, so we found part A, part B, and part C, right? Okay, remember how much we started off with? We had 500 grams, right? And after 4 years, we only had 440. After 8 years, we had 387. After 20 years, we still had 264. Okay, so now let me explain this part here, y'all. When we're trying to find the half-life, what the half-life means is how long is it going to take for us to end up with half of the original amount, okay? So remember the original amount we had was how much? Was 500. So what's half of 500? 250. Okay, so great, perfect. This is what we're going to do, y'all. For part B, we're going to say half of 500 is 250, and that's equal to the problem that we had. Now notice, I don't know what T is, right? That's what I'm trying to find. I'm trying to figure out how long it's going to take for me to end up with half of what I started off with. Okay, so what I did is, where the amount used to be, whatever amount we originally had, we took half of it and we put that in where that part used to be. Now, since we're trying to solve for the letter T, y'all, the first thing I'm going to do here, I'm going to divide both sides by 500. Okay, so that's going to go away. If I take my calculator and I take 250 and I divide it by 500, I come up with 0.5. Remember what you know what 0.5 is? 0.5 is half, right? That's what we call it, the half-life. Okay, so this is what I'm coming up with so far. Now, y'all, I'm trying to solve for t, but because t appears as an exponent and I'm using the e, I'm going to take the natural log on both sides. Okay. Now, the reason why I'm taking the natural log on both sides is the natural log and the e will cancel each other out. This is going to be equal to a negative 0.032t, okay? Because the natural log and the e cancel each other out. And if I'm trying to solve for the letter t, I'm just going to divide everything by that negative 0.032. Okay? And so I'm going to take my calculator here, y'all, and this is exactly what I wrote down is exactly what I'm going to enter in. So I'm going to hit, look, the natural log of 0.5 divided by negative 0.032. Oops, 32. And I'm coming up with 21.66, and I think in my lab, y'all, it does ask you to go to 2 decimal places on this one. So I'm going to write 21.66, or maybe 3. It might go to 3. So I'm going to write 21.661. 21.661, and this is in years. So it's going to take us a little bit more than 21 and a half years to end up with half the amount of whatever that radioactive material was, okay? But in essence, this is all I'm doing. So if you look at parts A, B, and C, that was like strict calculator problems. I'm just plugging the numbers in, right? The only one that I have to do a little bit of work on is part D so that I can get that, I can solve for that letter T, okay? All right. So let's see. Let's go ahead and go to the next problem that we got over here. I'm going to scroll, scroll, scroll. Here we go. Okay. So this problem here, y'all, is just like part D of the problem that we did, because it says, let's find the half-life of something called radium-226, which decays according to this function here. Okay, now notice, they didn't give us an initial amount, right? But that's okay, we don't need to know that. I'm going to show you what I'm going to do here. We're going to say A equals, A of t equals whatever that initial amount was, times e to the negative 0.00, looks like there's 3 zeros, 43 with a t. Okay, so remember what we said, that whatever amount we have, it's going to get reduced to half of that amount. So whatever number this is here, this is going to be half of that amount, okay? And don't get too nervous that I'm putting like an A0 there. It's not really going to make any difference in a second, okay? The reason being, whenever we divide by whatever this number is on both sides, those are going to cancel, those are going to cancel, okay? We're going to end up with 1/2 equals e to the negative 0.000, there's 3 of them, 43t, okay? Now, I told y'all this problem here, y'all, is just like part B on the problem that we did a little while ago, right? I want you to take a look at something. Remember how we did part D? Because we were dividing everything by 500. We came up, when we did on the calculator, we came up with 0.5. Look what I'm writing here. I'm writing 1/2. If it makes you feel better, write 0.5. Because 1/2 and 0.5 mean exactly the same thing, right? And guys, it's always going to be 0.5. Why? Because that's what we call it, the half-life. You know what I mean? So all you're going to do every single time you have a problem like this, regardless of the numbers that they give you, you're going to set 0.5 equal to that amount, okay? And just like we did before, we say, hey, look, I got an E here. If I got an E here, I need to take the ln on both sides. So I'm going to have the ln of 0.5 is equal to the ln of a negative 0.30, 1, 2, 3, 43 with a t. And I know that this part here is going to cancel out. So I'm going to have the natural log of 0.5 equals negative 0.123, 43 with a t. Okay. All right, and then my last step here, y'all, is just to divide. So let me grab my calculator again. And this problem, again, if you look at my calculator screen, I have the natural log of 0.5 divided by a negative 0.032. Now I'm going to have the natural log of 0.5 divided by a negative 0.123, 43. And how long is it going to take? Whoa, a long time. 1,611.971 years. 1611.971. Again, this is in years. So it takes a long time for that stuff to break down, right? 1,600 years. Okay, so I think we got one last problem on here from 4.6. So let's go through that one and see if we can't figure it out. So like I said, y'all, this one here with the Newton's law of cooling, you didn't have a problem like that in your homework, but we got this one here. Okay, let's take a look-see here. It says, the growth of bacteria. The growth of bacteria makes it necessary to time date some food products so they can be sold and consumed before the bacteria count is too high. Suppose for a certain number of bacteria present is given by, and it gives us a function right here, where t is the time in days, and the value f of t is in millions. So that's millions of bacteria. Find the bacteria in millions present at each time. Okay, so again, y'all, this is going to be very much plug and chug. 2 days. So we're going to find f of 2, which is 500 e to the power 0.1, in this case, times 2. Okay. So look, let me grab my calculator right here. 500 second ln, because I'm trying to get to my e, and I'm going to type in 0.1 times 2. That's my power, right? And I'm going to hit enter, and the number that I'm coming up with is 610.701. So f of 2 is 610.701, and this is in millions. So what does that mean? 2 days later, there's 610 million bacteria all over that funky stuff, right? All right, so y'all ever eat pizza that's a couple of days old, or the next day it's been, you left it out overnight? Oh my goodness, don't do that. It's not going to be good, right? Okay, so let's take a look at the next one here, y'all. 500 e to the power 0.1 times 4. That's all I'm doing now, 4 days, right? So again, if I want to save just to, save a little bit of time on my calculator, I'm going to go second, enter, and it'll type in exactly what I had before. And then I'm going to use my little arrow button, and I'm going to change from that 2 to a 4. And I'm coming up now with 745.912. 745, oops. .912, again, this is in millions, right? That's a point there, y'all, not a comma. Bacteria, right? And then we got a part C, and part C says 1 week. 1 week is the same thing as how many days? 7 days, right? That's all it's really telling me. So part C, we're going to go 7 days, right? So f of 7 equals, again, I'll take my calculator, do my little shortcut, and I'll change that from a 4 to a 7. And I'm coming up with 1,006.876. 1,006.876. Again, so this is in millions, right? All right. And that right there, y'all, was 4.6. Let me ask you a question. Out of everything we did today, I'm gonna put it this way. I'm gonna scroll. Okay. I don't know about you guys, but I think this problem right here was probably the hardest one that we did today out of all the problems that we did. And the only reason I say that is because even this problem, you know, I don't think it's necessarily hard because we've talked about factoring. Like chapter 1, we did so much factoring. And even when we were in problems in chapter 2, we had to do some factoring. And even a little bit in chapter 3, we had to do some factoring, okay? So, yo, we still got about 20 minutes. Are there any particular homework questions that you guys had that you want to ask me? If you do, we got some time. If not, y'all know that you can always send me a question on Chrono, sir. Can we go over this one? Can we do this one? I'm happy to make the videos for you guys. Send them out as soon as I get them. So y'all, I'm just gonna come back again one more time. And I want to say that I also sent you guys an announcement about the test. So I'm going to click on announcements up here. Yes, here we go. Okay, so last week I had sent you guys, and I think I sent it through Kano as well. Okay, so again, just some information about test 2. The review has 42 questions. It is a homework grade, y'all, but more importantly than a homework grade, it's kind of like the sneak preview. You already know what the test is going to look like if you do the review, right? Sometimes you'll say, oh, well, I didn't do the review. It's not a big deal, but I don't care so much about like, oh, well, I have a 0 for my homework. If you don't do the review, chances are you're not going to do well on the test, right? And that's like the more important part because the test like counts more than one homework, right? So next Tuesday, y'all, all we're going to do is just say, okay, let's pull up the review. What questions do you guys have? We'll go over those, right? And then the test, guys, is going to open up next Tuesday night. So I'm going to open it up at 8 o'clock. It'll be open from next Tuesday up until Wednesday the 24th. That's the night before Thanksgiving, okay? So if you know that you're going to be doing Thanksgiving stuff, prepping stuff on Wednesday, make sure you take the test before that day, okay? Guys, it'll be open for the whole week. And I know I told you guys on the first test, anytime you have little computer glitches, just close the window. Don't hit submit, just close the window and then open it back up again. If you accidentally hit submit, send me a message on Prano, okay? Now guys, if you send me a message like say Saturday, I probably won't see it until later because I keep Prano on my iPad, right? And my iPad usually stays in my office on the weekend. But if something like that happens, let me know. We'll take care of it, okay? Y'all, just like I told y'all before, if the problem that we did earlier tonight, what was it? This one here, and let's see, this problem that we did here, let me come back to it. And okay, so again, for something like this, y'all, if you put like x equals and it counts it wrong, just send me a message. Take a picture of it, sir. Can you check this one, this one, this one? I'm happy to do it, okay? You guys feel like you know what to do between now and next week? Okay. So thank you all for showing up tonight, y'all. Appreciate it. Those who are at home, thank you for logging in. I appreciate it. Let me see. Oops, that's not what I wanted to go to. I wanted to go to this part here. There you go. Let me stop sharing my screen, y'all. Those of you who are at home. And let's see. Oh my goodness. Here we go. Okay, so those who are at home, Laura, Roberto, and Antonio, remember next week, y'all, review. So work on that review between now and then, and that's what we'll worry about next week, okay? So thank y'all for showing up, y'all. I'm going to stop recording.